Hello everyone, welcome to YourPedia Education. Today we start electrical machine subjects, and this subject we will cover with the help of question. I'll try to cover all types of question which clear all concept related to the DC machine. So first of all we clear what is the syllabus of this subject. In electrical machine, electrical machine syllabus we cover is first DC generator and DC motor. DC machine has two parts. One is first we cover DC machine has two parts. One is generator and other is motor. Second, we cover transformer. Transformer has two supplies connection. One is three-phase connection and other is single-phase connection. Third, we study induction motor. Induction motor has two types. One is three-phase induction motor and other is single-phase induction motor. Fourth, we study synchronous machine. Synchronous machine works in two segments. One is synchronous generator and other is synchronous motor. Synchronous motor. Next, we study a special machine. A special machine in which we study generally a stepper motor, servo motor, or some other types of machines. Today we will start DC generator and we cover some question of this part. We first study DC machine, and in DC machine we first cover DC generator part, then we cover DC motor part. According to the Cochin Shipyard Limited paper analysis, the level of question is JE level, not much advanced or not much below. Only this exam need your basic fundamental of the subject or syllabus is cleared. So I'll try to cover the question level which maintain the paper pattern. So let's start. First question is a shunt generator. A shunt generator delivers 450 ampere. Delivers 450 ampere at 230 volt. 230 volt. And the resistance of shunt field winding and armature are 50 ohm and 0.03 ohm. Calculate the generated EMF. This is the information given in this question. Here simply said machine is shunt and current supplied to the load is 450 and voltage across the load is 230. Their armature resistance and field resistance is given. We need to find the generated EMF. First of all, we draw the electric circuit of shunt generator. This is the electric circuit of shunt generator where V is the voltage across the load or terminal voltage, EG is generated EMF, IA armature current, IL load current or terminal current flowing through the load, ISH is shunt field current. Here we need to find EG. To find out the EG, we apply KVL equation in this loop. When we use KVL equation, we write the equation EG minus IARA minus here to write down the KVL equation, either we use sign or polarity of the element, initial polarity or final polarity of all the elements. Here we write the KVL equation by taking the final polarity or finishing polarity of the element. Like this is the load and their initial polarity is positive because we know the current is always flow from high voltage to low voltage. So this is initial polarity and this is the final polarity for that element. So here we take the final polarity of all the element. So Eg minus IARA minus V equal to 0. Eg equal to, if we further rearranging this equation, Eg equal to V plus IARA. V plus IARA. Here we need voltage, armature current and armature resistance to find out the value of generated EMF. In this question, value given is terminal voltage, load current, armature resistance, shunt field resistance, but here armature current is not given. So first of all, we need to find the armature current. To find out the armature current, apply KCL at that node. IA, we know according to Kirchhoff's law, incoming current at a node is equal to outgoing current at a node. So here we write IA equal to IL plus ISH. In this question, IL is given, ISH not given. First of all, we find ISH. ISH is the current flowing through the field winding. So to find out this winding is connected across the load and voltage across the load is V. So ISH is equal to voltage V upon resistance of the shunt field winding. ISH equal to V by RSH. Here V is 230 and RSH is 50. So 230 divide 50. If we simplify this, we get the value of shunt field current and their value is 4.6 ampere. Here ISH is obtained. Now obtained IA. IA equal to IL plus ISH. In this question, IL is 450. So 450 plus 4.6 equal to 454.6 ampere. 454.6 ampere. This is IA armature current. Now to find EG, EG equal to V. Here V is 230 plus IA is 454.6 into RA, armature resistance. Here armature resistance is 0.03. 0.03. When we simplify this, we get the value of generated EMF and the value is 243.6 volt. So the generated EMF for this machine is 243.6 volt. Next, we solve next question. Next question is a short shunt compound generator. A short shunt compound generator delivers a load current of 30 ampere. Current delivered to the load is 30 ampere at 220 voltage. Terminal voltage is 220 and has armature series field and shunt field resistance. RA is 0.05, RSE is 0.3 and RSH is 220 ohm respectively. Calculate the induced EMF and armature current. Allow 1 volt per brush for contact drop. Brush contact drop per brush is equal to 1 volt. Here, question is a short shunt compound generator is given. Their terminal voltage current flowing through the load is mentioned. Here we need to find the generated EMF and armature current. To find out this value, first of all, we draw the electric circuit of short shunt compound generator. This is electric circuit of short. Here we draw the short shunt compound generator, and in short shunt compound generator, series field is connected in series with load. This is short shunt compound generator. Short shunt compound generator. Here we need to find the generated EMF and armature current. To find out the armature current, first of all, apply KCL at that node. IA, incoming current at a node, is equal to outgoing current, that means IL plus ISH. IL plus ISH. Here IL is given, so we need to find ISH. ISH equal to ISH equal to, here we need to find ISH. To find out the ISH, we need voltage across the shunt field winding. So here in previous question we take voltage across the load is equal to voltage across the shunt field winding, but here we don't take this value because here load is here series field winding is connected, and due to this voltage drop happened. That's why voltage across the load is not equal to voltage across the shunt field winding. To find out this current, we need to find out first voltage across the shunt field winding. Let voltage across this winding is AB. Here there is no any element. Voltage across AB is also equal to voltage across that element. So VAB. Apply KVL in this loop. When we apply KVL, voltage across node A to B, here we take VAB minus current is flowing in that direction, and we know current always flow from high voltage to low voltage, and to write down the KVL equation, we use sign of each element, which is final sign. We don't take the initial sign, we use here final sign. So if we write this equation, VAB minus IL RSE minus V voltage across the load equal to KVA. According to KVL equation, KVL is say algebraic sum of branch voltages in a closed loop is equal to 0. So VAB minus voltage across that node VAB minus ILRSE minus V equal to 0. Here VAB minus IL, in this question IL is 30 ampere, 30, and RSE is the series field resistance, and here series field resistance is 0.3, and voltage across the load is equal to 220. When we simplify, we get the voltage across VAB, and this is equal to 220, and when we multiply this, we get 9, 220 and 9 when we add it, then their value is 229. Here VAB is found. So ISH is voltage across the field winding VAB divided by the shunt field resistance of this winding. That means RSH. Here VAB is 229 and RSH is the shunt field resistance. Their value is 220. When we simplify, we get the value of the shunt field current, and their value is 1.04. Now IA, here we find it the value of ISH. So IA equal to IL plus ISH. IL is 30 and ISH is 1.04. So IA is 31.04 ampere. In this question, first part is what is the value of armature current. So for this question, armature current is 30.04. Now we need to find the generated EMF. To find out generated EMF, now we apply KVL equation in this complete loop. Initially, to find out the voltage across the AB, here we let voltage across terminal A to B is VAB. Now, to find out the VEG, we apply KVL in complete loop. So, when we apply the KVL in complete loop, we write the equation EG minus IA minus BCD. We know how the DC machine's DC generator work. In DC generator or DC machine, main component is two. One is a stator and other is rotor. A stator is a stationary part and rotor is rotating part. In DC machine, on a stator winding placed, and on rotor armature winding placed. When we apply excitation to the stator winding or field winding, field flux developed. When we apply mechanical input to the rotor, because generator converts mechanical input to the electrical input, when we apply mechanical input to the rotor, rotor starts rotating and armature conductor on rotor cuts the field flux. Due to this, EMF induced in the armature winding. That EMF induced is EG. When the armature terminal is connected to the load, due to this current flowing, and when current flowing, voltage drop happened due to the field winding RSE and armature resistance. So here we take EG minus IARA. Also voltage drop happened due to the BCD, but if in question BCD drop is not mentioned, then we generally neglected. But if BCD drop is given in question, then we must consider the BCD drop. So here the equation is EG minus IARA minus BCD minus ILRSE minus voltage across the load is equal to 0. We know according to KVL, algebraic sum of branch voltages in a closed loop is equal to 0. So EG minus IARA minus BCD minus ILRAC minus V equal to 0. Now we need to find EG. So put all this value here. All value is finded. EG minus IA. IA is 31.04. 31.04 and RA is armature resistance. In this question, armature resistance is 0.05. 0.05 minus BCD. BCD is brush contact drop in any electrical machine. If not mention number of brushes, then we generally take minimum number of brushes in any electrical machine is 2. So here given per brush drop is 1 volt and we say minimum number of brushes in any machine is 2 and 1 volt per brush drop is given. So the total voltage drop is 2 into 1 minus ILRAC. Here IL is 30 and RSA is the series field resistance 0.3 minus V terminal voltage 220. When we simplify this equation, we get the value of generated EMF, and the value of generated EMF is equal to 232.56 volt. 232.56 volt. Next, we solve next question. Next question is, the following information is given for a 300 kilowatt 600 volt long shunt compound generator. Question is, a long shunt compound generator having output power is equal to 300 kilowatt. Terminal voltage is 600. The following information is given for a 300 kilowatt 600 volt long shunt compound generator shunt field resistance RSS is equal to 75 ohm. Armature resistance RA including brush resistance RA including brush resistance is 0.03. Commutating field winding resistance is here we represent commutating field winding by R COMM as a subscript to represent commutating field winding, and their value is 0.011. Series field resistance is 0.012 and diverter resistance is 0.036 ohm. When the machine is delivering full load, calculate the voltage and power generated by the armature. When machine delivering full load, calculate the voltage and power generated by the armature. We need to find generated voltage and generated power. To find out this value, first of all, we draw the electric circuit of long shunt compound generator. Here, generally, in long shunt compound generator, electric circuit is This is the electric circuit of long shunt compound generator in general, but here some additional resistance is mentioned, like uh, armature resistance is generally armature resistance of the armature RA. RA here also include commutating field winding resistance and diverter resistance. In DC machine, we need commutating field winding resistance to counter the armature reaction effect, and this resistance is connected in series with armature. We remember commutating field winding resistance is connected in series with armature. So if not mention commutating field winding resistance, then in this case the simple electric circuit of short shunt compound generator long shunt compound generator is this. But if additional information is given like commutating field winding resistance, then we remember the commutating field winding resistance is connected in series with armature. So here we connect the commutating field winding resistance. Commutating field winding resistance are commutating. And also here given the diverter resistance. Diverter resistance used to adjust the terminal voltage of the machine, and the diverter resistance is always connected across the series field winding. You remember that? First we say commutating field winding resistance. Commutating field winding resistance is connected in series with the armature, and diverter resistance is used to adjust the terminal voltage of the machine, and this resistance is always connected across the series field winding. It is not regardless of what is the position of series field winding, does not depends. We only remember that the diverter resistance always connected across the series field winding. We don't care what is the where is the series field winding connected. Simply if the diverter resistance is given, we connect diverter resistance across the series field winding. So here diverter resistance is given, so we connect the diverter resistance across the series field winding. Across the series field winding. Now we need to find the generated EMF. To find out the generated EMF, we apply KVL equation in this loop. If we apply the KVL equation, we write EZ minus IARA. Here brush drop is not given. So if brush drop is not given in question, then we generally neglect the brush drop. So EZ minus IARA minus IA are commutating resistance, because commutating resistance is connected in series with armature, so armature current is also flowing through the commutating field winding resistance. Now here if we find the equivalent resistance of RD and RAC, then here the equivalent resistance in equivalent resistance current is also flowing armature current, because equivalent resistance is also in series with the armature. Or we simply know that incoming current at a node is equal to outgoing current. If armature current is divided at that point in diverter resistance and series field winding resistance, after the exit of at that point, incoming current at a node is equal to outgoing current at a node. So here the armature current is IA. Here simply we need, here we don't take the diverter resistance current and series field resistance current separately, we simply find out the equivalent resistance RD and RSE, and thereby these equivalent resistance is connected in series with the armature, so armature current is flowing in them. So here we write IA into RSE parallel to RD, because here RD and RSE is parallel. If we find the equivalent resistance and put here, then we solve this electric circuit easily. So EG minus IARA minus IAR minus IARD parallel RSE minus voltage across the load V is equal to 0. Now to find out the generated EMF, we need IA. Here output power is given and voltage across the load is given. So first of all we need to find armature current. Here we take this is equation 1. To find out the generated EMF we need IA and RSE parallel RD and remaining values are given in this question. To find out this value, first of all, we apply incoming current at a node is equal to outgoing current. We know incoming current at a node is equal to outgoing current. We further simplified this electric circuit, so we easily understand this question. This is the electric circuit, and here we clearly seen when armature current flowing, this current comes at that node and it divides one current flowing to the series field winding and other diverter. Then this current again comes at that point, and incoming current at node is equal to outgoing current, and here incoming current at node, current flowing through the diverter plus series field winding is equal to the armature current. So if we apply the KCL at that node, then incoming current IA is equal to outgoing current IL plus ISH. IL plus ISH. Here we need to find IL and ISH. So we get the armature current. To find out this, here output power is given, and output power, if we write the equation output power, then output power is equal to voltage across the output power or load power. Voltage across the load V and current flowing through the load IL. So output power is product of V into IL. Here output power is 300 kilowatt. 300 kilowatt, that means 300 into 10 to power 3, and voltage across the load is 600 into IL. By simplification, we get the value of IL. Here IL is 300 into 10 to power 3 divide 600. If we simplify this, we get this is 3000 and divide 5, it gives the value of current IL, and their value is 500 ampere. Now we need to find the ISH to get the IA. So here ISH is this is shunt machine, so voltage across the load is also equal to voltage across the shunt field winding, because we know voltage across in parallel connection voltage does not changes. So voltage across the load is this voltage is equal to voltage across the load. So ISH equal to V by RSH. Here V is 600 and RSH is 75. When we simplify this, we get the value of ISH, and their value is 8 ampere. 8 ampere. 8 ampere. ISH equal to 8 ampere. So IA equal to IL plus ISH. Here IL is 500 and ISH is 8. So 500 plus 8 equal to 508 ampere. 508 ampere. This is IA. Now we need to find the EG. Now here all this value IA is finded. Now here we need to calculate RSE parallel RD, and we know when two resistances are connected in parallel, in this case their value is, we need to find RSE parallel RD. And when the two resistances are connected in parallel, we simply know if two resistance is R1, R2, in this case, R1, R2 upon R1 plus R2 is the equivalent resistance. Similarly, if we write RSE parallel RD equivalent, then we write RSE into RD upon RSE plus RD. Here, RSE is 0.012 and RD is diverter resistance, and their value is 0.036. 0.036 upon 0.012 plus 0.036. When we simplify this, we get their value, and their value is 0.009. Now, all this value put in equation 1. From equation 1, EG minus IA. IA is equal to 508. RA. Here RA is armature resistance, and their value is RA including brush. We simply take RA. RA is 0.03. 0.03. EG minus IARA minus IAR commutating. R commutating is 0.011 minus IAR commutating, that means 508 into 0.011. 0.011 minus IA into RSE parallel RD minus IA. Here IA is 508. RSE parallel RD. Here RSE parallel RD is equal to 0.09. 0.009. EG minus IARA minus IAR commutating minus IA into RSE parallel RD minus V. Here V is 600. When we simplify this, we get the value of generated EMF, and the generated EMF EG is equal to 6 to 5.4 volt. Now we need to find here in this question, we need to find generated EMF and power generated. First we find it the generated EMF for this question is 625.4 volt. Now we need to find the generated EMF, generated power, and generated power is equal to we know power is product of voltage and current, and here we need to find generated power. So generated EMF into current flowing through the armature gives generated power. Here the generated EMF is 625.4 and IA is armature current. Value of IA is 508. 508. Simplify this, we get the value of generated power, and when we simplify, you get this. Simply here we write power consumed by the load is having unit watt. So generated power is 625.4 into 508 watt. Next, we try to solve the next question. Next question is, a four-pole generator having wave-wound armature. Here we remember, in DC machine, two types of, in DC machine or in any machine, two types of winding. Armature winding is of two types. One is lap winding. Armature winding is lap winding and wave winding. Lap winding and wave winding. Winding is lap or wave if, here the winding is lap. Winding is either single turn or multi-turn coil. If there is not mentioned any in multi-turn or single turn, we simply take the simplex winding. Winding is either simplex winding or duplex winding or triplex winding. Here not mentioned what is the type of the winding, so we simply take the simplex lap winding or simplex wave winding. Simplex wave winding. Simplex wave winding. If the winding is lap, simplex lap, generally according to your level of question, generally taken the winding is simplex or simplex lap or simplex wave. If the winding is simplex lap, in this case, number of parallel path in the armature winding is equal to number of pole. In simplex wave winding, if the winding is simplex, then in this case, number of parallel path is 2. In wave connection, number of parallel path is equal to 2, but in lap connection, number of parallel path depends on number of pole. So here question is, a four-pole generator having wave-wound armature. Wave-wound means number of parallel path is equal to 2. Wave-wound armature winding has 51 slots. Number of slots in the armature winding is 51. Number of slots is equal to 51. Each slot containing 20 conductor. Each slot containing number of conductor in each slot is equal to 20. What will be the voltage generated in the machine when driven at 1500 rpm? A speed of rotation is 1500 rpm. In this case, what is the generated EMF? Assuming the flux per pole is phi equal to 7 milliweber. 7 milliweber. Now, here we need to find the generated EMF. To find out the generated, one method to find out the generated EMF is using the KVL equation of particular DC machine electric circuit. If there is not mentioned any type of DC generator, then we take simple generator and To find out the EMF, either you use EMF KVL equation in the loop or using the general formula of generated EMF is equal to phi P and Z upon 60 into A. But here in this question, if we saw there is no any value is given to find out the generated EMF by using KVL equation in the electric circuit loop. Here mention number of pole, number of parallel path, number of conductor. So to find out the generated EMF, we use formula is equal to phi Pn Z upon 60 into A. 60 into A. Here phi is mentioned, P mentioned, and N mentioned, but here Z is not mentioned. A is also mentioned. Now to find out the Z, here question is total number of slots in the armature is 51 and each slot containing 20 conductors. So total number of conductor is Z equal to number of slots into conductor on each slot into conductor in each slot. Here total number of slot in this machine is 51 and each slot contains 20 conductors. So total conductor of this machine is 1020. Now put all this value in this equation. Is equal to phi. Here phi is 7 milliweber. 7 into 10 to power minus 3. P is number of pole. Here number of pole is 4. 4. Phi Pn. N is 1500. 1500. Phi Pn and Z is the number of conductors. Z is equal to 1020. 1020 upon 60 into A. A is number of parallel path and here number of parallel path is 2. When we simplify this, we get the value of generated EMF, and here the value of generated EMF is equal to, if we simplify, we get the value, their value is 357 volt. 357 volt. Now we solve the next question. Next question is an 8-pole DC shunt generator having number of pole is 8 with 778 wave connected armature conductors. Conductor is 778 and connection of the conductor is wave, and here we discuss if not mentioned the connection is simplex, duplex or triplex wave, we simply take the simplex wave winding, and in simplex wave winding number of parallel path is equal to 2. So number of parallel path is 2. An 8-pole DC shunt generator with 778 wave connected armature conductors and running at 500 rpm. A speed of rotation is 500. Supplying a load of 12.5 ohm resistance. Load resistance is 12.5 ohm. At terminal voltage V equal to 250 volt. The armature resistance is 0.24 ohm and the field resistance RSH equal to 250 ohm. Find the armature current, induced EMF and flux per pole. So to find out this value, first of all, we find out IA, we need here we first draw the electric circuit of shunt generator. This is the electric circuit of shunt generator. Here load is given and their value of resistance is RL 12.5. So here we simply use RL is the load resistance. RL is the load resistance. Here we need to find IA. To find out IA is equal to apply KCL at that node. Incoming current is equal to outgoing current. That means IA equal to IL plus ISH. Here IL and ISH is not given. So we need to find IL and ISH. How to find the IL and ISH? Here RL is given and voltage across the RL or terminal voltage is given. So here if we write, then we know voltage V is equal to product of current into resistance. So voltage across the load V is equal to resistance of load RL and current flowing through the load is IL. Here V and RL is known, so IL equal to V by RL and V is equal to 250 and RL is 12.5. 250 upon 12.5, if we simplify, we get the value of IL and their value is 20 ampere. Now IL is find it. Now we need to find the ISH. ISH is shunt field current, and in shunt machine, voltage across the load is also equal to voltage across the shunt field winding because this winding is connected in parallel to the load. So ISH equal to V by RSH. ISH equal to V by RSH. Here V is 250. V is 215 and RSH is the shunt field resistance. Their value is 250. 250. By simplification, we get ISH and their value is 1 ampere. Now put IL and ISH in this equation. We get IA equal to IL plus ISH. Here IL equal to 20 and ISH is 1. So 20 plus 1 equal to 21 ampere. 21 ampere. IA is 21 ampere. So first part is need to find IA and value of IA is find it. Their value is 21 ampere. Now we need to find the easy. To find out the easy, apply KVL in this loop. If we apply the KVL in this loop, we write the equation and their equation is easy minus IARA minus voltage across the load. Easy minus IARA minus, here voltage across the load is given, so we directly take the voltage across the load V. Current is flowing always from high voltage to low voltage, so the polarity is initial polarity positive and final polarity of that element is negative. And to find out the KVL equation, we use polarity of every element after of finishing polarity or ending polarity of every element. So easy minus IARA minus V equal to 0. Here easy minus IA is 21 and RA is the armature resistance. Here armature resistance is 0.24. 24. Minus V, V is the voltage across the load and their value is 250 equal to 0. Simplify this, we get the value of generated EMF and their value is EC equal to 255.04 volt. 04 volt. Now we need to find the flux phi. To find out the flux phi, we use generated EMF formula EZ. We know EZ equal to phi PNZ upon 60 into A. Here EZ is 255.04. We need to find phi. Here in this question, number of pole is P and their value is 8. 8 into a speed of rotation. A speed of rotation is 500. Number of conductor is 778 upon 60 into A. A is number of parallel path and this is wave connection. So number of parallel path is 2. When we simplify this, we get the value of flux phi and their value is approximately equal to 9. When we solve, we get this value and this is approximately equal to 9.83 milliweber. Milliweber. Now, we proceed to the next question. Next question is, here we discuss variety of question. That's why all types of concept which is required to solve the DC generator question is cleared. So we try to solve next question, and this question is a 4-pole DC generator. Here DC generator having pole 4 runs at a speed of 750 rpm and generates an EMF of 240 volt. The armature is wave wound. The armature is wave wound. That means number of parallel path is equal to 2. The armature is wave wound and has 792 conductors. Z equal to 792 conductors. If the total flux from each pole is 0.0145 Weber, calculate the leakage coefficient. Leakage coefficient. Generally, we represent leakage coefficient by using symbol lambda. Leakage coefficient lambda is equal to useful flux per pole upon, here by mistake we say a wrong formula. Lambda leakage coefficient is equal to total flux per pole upon useful flux per pole. Useful flux per pole. Total flux per pole upon useful flux per pole. In equation EZ equal to phi P NZ upon 60 into A, here we write phi and this is the useful flux. This is useful flux per pole. Useful flux per pole. Or we simply say flux per pole, but here specify that the leakage coefficient is equal to total flux per pole upon useful flux per pole. In this question, given total flux from each pole, this is total flux from each pole total flux from each pole is 0.0145. To find out the leakage coefficient, we need to find useful flux per pole. Then we solve this. So, first of all, we find useful flux. How to find the useful flux? So, to find out the useful flux, we use generated EMF formula, and EC is equal to phi P and Z. Z upon 60 into A. 60 into A. In this question, AC is equal to 240. 240. Phi, we need to find number of pole is 4. 4. And a speed of rotation is 750. 750, and Z is the number of conductor. Number of conductor is 792. 792 upon 60 into A. A is number of parallel path, and number of parallel path is equal to 2. By simplification, we get the value of phi, and their value is equal to 0.0121 Weber. Now, we use the formula leakage coefficient is total flux per pole. Here the total flux per pole is 0.0145, and this is useful flux per pole. Useful flux per pole. Per pole, or we simply said flux per pole. Flux per pole. So lambda that means leakage coefficient is total flux per pole. Total flux per pole is 0.0145. 0.0145, and useful flux per pole is 0.0121. When we simplify, we get the value of leakage coefficient, and then value is 1.198. 198. Next. Next question is a 4-pole DC shunt generator. DC shunt generator having number of pole is 4. A 4-pole DC shunt generator with a shunt field winding RSS is equal to 100 ohm, and an armature resistance is equal to 1 ohm, has 378 wave connected conductors. Z equal to 378, and connection of the winding is wave, that means number of parallel path is 2 in its armature. The flux per pole is phi equal to 0.02 Weber. If a load resistance of 10 ohm is connected across the armature terminals, load resistance is 10 ohm. Terminal, and the generator is driven at a speed 1000 RPM, calculate the power absorbed by the load. Here we need to find power absorbed. Absorbed by the load. Power absorbed by the load. Power absorbed by the load. To find out the power absorbed by the load, we need to find the, first of all, we draw the electric circuit here. This is shunt machine, so electric circuit is this is the electric circuit. Here load is given and the resistance is 10 ohm. So here we directly use the load resistance RL. This is RL. RL. We need to find here power absorbed by the load. To find out the power absorbed by the load, either we know the power is the product of voltage into current. So power absorbed by the load, power absorbed by the load, absorbed by the load. Either you write, we know the power absorbed P is equal to IA square R, or product of voltage into current. So if we use voltage and current, then we write power absorbed by the load is V into IL, or we simply write IA square RL, that means IL square into RL. Now to find out this value, we need to find out IL. All this value is here. V is voltage across the load, and voltage across the load is not mentioned, so we need to find out the voltage across the load, then current, or simply we need to find out the current. If we find the current, load resistance is given. Simply using this formula, we find out the load power. So here we take this as a equation 1. Now how our motive is only to find out the current flowing through the load. If we find it this value, we find out the power absorbed by the load. To find out this value, first of all, we write the current flowing through the load, current flowing through the armature IA is equal to, if we apply the KCL equation at this node, IA is equal to incoming current equal to outgoing current, that means IL plus ISH. IL plus ISH. IL is a load current. Here we know current I equal to potential difference upon resistance or impedance. If we write the current flowing through the load, then voltage across the load is V and current flowing through the load is IL. So IL equal to V by RL. Similarly, we write the current flowing through the shunt field winding. This is shunt machine, so voltage across the load is equal to voltage shunt field winding. So ISH equal to V by RSH. Now here V is not given, but RL and RSH is given. So we take V as a common, 1 by RSH. RSH is equal to 100 and RL is 10. So 1 by 100 plus 1 by 10. If we simplify, we get this as V. Take LCM of denominator here. LCM is 100. So 100. If we simplify this, 100 divide by 100, 1, and this one is multiplied to the numerator, so 1 plus. Similarly, 100 10 divide 100, we get 10, and 10 multiply numerator, so here this is 11 by 100 V. 11 by 100 V. Now here we find the current IL in terms of voltage. Now we using the equation easy. When we write the equation easy, first of all, here we need to find the easy. That's why we simply obtained the equation. So here we take IA is find it in terms of voltage V. Now first of all, to when we write the KVL equation in this loop, first of all we need to find the easy, otherwise equation not solved. So first of all we find the easy. Here easy is equal to 5 PNZ upon 60 into A. Here phi is flux and their value is 0.02. 0.02, and number of pole is equal to 4. 4. A speed of rotation is 1000 and number of conductor is 378 upon 60 into number of parallel path is equal to 2. If we simplify this, we get the value of generated EMF, and the generated EMF is 252 volt. Now we apply the KVL equation in this loop. If we write the KVL equation, EG minus IARA, EG minus IARA minus EG minus IARA minus voltage across the load. We simply write voltage across the load is V, because we don't know what is the value of IL. RL is given, so we simply write EG minus IARA minus V equal to 0. Here EG is 252 minus IA is, here we find it the value of IA in terms of voltage, and their value is 11 by 100 into V. Put this value here, 11 by 100 into V. RA is armature resistance. Armature resistance for this electric circuit is 1. 1 minus V equal to 0. Now, if we see here, clearly shows that this equation has only one unknown, and that unknown is V. So by simplification we get the value of V here, 252 equal to V plus, put 11 V by 100 and V to right side, then V minus V equal to plus V, and this is also plus 11 V by 100. If we simplify this, 252 equal to 100 V plus 11 V, that means 111 V upon 100 V. By simplification, V equal to 252 into 100 upon 111. Simplify this, we get the value of V, and their value is approximately equal to 227 volt. Now, when we find it, we find the value of IL by using this. Now IA equal to 11 by 100 into V. 11 by 100 into V, and the value of V is 227. Simplify this, we get the value of IA. But here, to find out the value of this, we need to find out the IL. So to find out the IL, directly we use IL equal to V by RSS, because RSS is given in this circuit. So directly we use here, no need to find out the IA, because we need to find out the value of power absorbed, and to find out the power absorbed we need voltage and IL. Voltage is finded, and IL, to find out the IL, here we simply directly use IL equal to voltage across the load in divided by resistance of the load V by RL. Here V is 227 and RL is the load resistance. Their value is 10. When we simplify this, we get the value, and their value is 22.7 ampere. Now, from equation 1, power absorbed by the load, is equal to, either you write product of V into IL or simply IL square RL. Here IL square is 22.7 into RL is the load resistance. Load resistance is 10. Load resistance is 10. Simplify this. We get the value of, and their value of power absorbed is approximately 5.52.9 watt. This PDF contains some question. You may try to solve this, and you may try to solve this. This question I'll discuss in next lecture. Thank you.